Try to make sure we resume the recording here. All right, so and I'm going to make sure that this gets posted up as quick as I can onto YouTube, um, as I do with other things. But this is definitely one of the subjects that you guys are probably going to want to take a look at a little bit extra. Because working with classes is a different type of mindset. Um, it's not that difficult in all honesty. But it requires kind of shifting the way we look at things, the way we think of things. So let's look at kind of what we're going to do. And the whole concept, the whole overarching concept of working with classes is known as OOP, Object Oriented Programming. And the idea is if you think about the things that we have done previously, we've had, and we did this as well in Python. When we had Python, we looked at this variable. It was temperature, and that's all it was. Was one number, and it's a double in C++, and it's just holding a temperature value. I might have another variable. It's called age. It says it's an integer. It says how old someone is. I might have another variable, it's a string, and it's their name. Um, but in real life, that's not really how things work. Um, if you think about it, and let's go with a very obvious thing, something you guys can obviously directly relate with. Think about yourself as a student. Okay, if you had to come up with a single value to define who you are as a student, that would be a real challenge. Okay. Um, I was thinking about this the other day. I said, how could I define myself as a person using only a single element? Um, and the best I could come up with was 33. And 33 is kind of a funky number. It's made up of two prime numbers, 3 and 11. It's its own inverse, being that it's a palindrome. It's the same forward and backwards, so it's kind of quirky that way. um, you can start thinking, okay, 33 is kind of an interesting number to work with, so maybe that describes me. But there's a lot of things that it doesn't describe me about. My weird offbeat sense of humor notwithstanding, there's a lot of other parts of me that it doesn't describe. Um, and so there's no real good way to find a single value that's supposed to describe you as a student. Uh, because you're made up of a lot of different properties, and you have a lot of different what we refer to as behaviors. And so if we start thinking about them, I've listed, and they're on the screen there, some examples. Things like your name. And your name is not just your name. You have a first name and a last name, or depending upon where you come from, it might be referred to as a surname or a family name. Um, you've got a middle name. You might have a nickname. You might have a suffix. For example, I'm the third. Um, and that causes some confusion when people don't take into account the suffix. Because if I just use a name to access it, am I talking about my father or my son? And all three of us share the exact same name. Um, so from that perspective, even something simple like a name, it can be complex. Um, then I'm going to have, obviously, if I'm talking about a student, I'm going to have things like what's a current GPA, and what's the person's major, when do you expect to graduate, um, who's your advisor. Those are ones I listed there. If you think about it, there's going to be a whole lot more. Are you a student athlete? In which case, um, what sport do you belong to, or sports if you're a multi-sport athlete? Um, you might have things like what's your hometown, a mailing address, an emergency contact information. You might have a phone number associated with it, and does it allow text? Do you want to receive text? Do you prefer text over email, or do you prefer email? A lot of different pieces of information would go into you as a student, and how would we access and incorporate that information into a software application. Okay, so you have this whole bunch of complexity all wrapped up in defining who you individually are. And just because something is the same with another person doesn't make them the same as you, and vice versa. So, for example, um, I went to University of Central Florida. There was, when I graduated, about 32,000 students. Um, there might have been a thousand of them that were student athletes at the time. Well, if that was the property you looked at, I could filter on that, I could check it off, I could do all types of stuff, but everyone who wasn't a student athlete is obviously going to still be completely different than other individuals. Um, and that's something I have to keep in mind. I could even have, I have known people with the same name. In some cases, in the same school. I have two friends who both are named Kevin Jones. Uh, Both of them I've known from school, one from college, one from high school. I happen to be friends with both of them still on Facebook. Um, but that's kind of common names, Kevin and Jones. That's not a real unique name. So even those two names together don't make those two entities the same, which is a good thing. They're actually very, very different people. Um, so we have that. Now the behaviors is, what do we do with those attributes, or what can you do because of you being a student, or whatever type of object we look at. We'll look at some others in just a few minutes. So things like, if I have your name as three separate fields, a first, a middle, and last, I might want to print your full name. On the other hand, I might want to print your name as like kind of a last comma first format. Okay, so I can take that data and just kind of rearrange it. Um, and that's a real simple type of idea of how do I get data out. Now, some behaviors isn't about the properties that you have. Some of it's going to be things like, I need to register for a class. So if you are a student and you're looking at classes you're going to take next term, you go and say, okay, I need to register for a class, and you say, okay, well, how do I do that? And there becomes a whole mechanism behind the scenes on the computer side that links you with a class and puts you in a separate data field to allow you to be registered. That way that you can keep moving forward. Um, Likewise, if you go to graduate, there's a couple of interesting things that have to happen in that case behind the scenes. And the object methods that we create to perform these behaviors needs to know all about that logic, need to know about all what's going to happen and what's going to go step by step by step. Uh, it's going to do things like verify if you've taken enough credit hours, or including the ones that you're currently taking, are you taking the right credit hours to make sure that you're eligible. While it would be kind of cool if your first semester says, "Hey, you know what? I know all stuff. Let's just graduate." Um, Odds are there's going to be some stuff later down the line that you may not know, and therefore you don't want to just say, "Oh, and here I am." Um, Likewise, you're going to need to check and make sure that you don't have late fees associated with forgetting to turn a book into the library, or other things like that. Um, and then all these different like little checks and processes have to go through. Those are all behaviors that happen behind the scenes. So while you just go in and say, hey, I'm ready to graduate, here's my form that I fill out to do that process. Behind the scenes, lots of other things happen, and the methods that control and check for that object behavior need to know about that stuff. So sometimes they're really simple, like just printing out your name. Sometimes they're going to be a lot more complicated. And in both cases, that's okay. You want the methods to be as simple as possible, but no simpler. And the basic idea of that is, we don't need a lot of extraneous extra information. We don't need to just do things just to do things. But at some level, we have to say, look, this is a complex thing, and we're going to make it complex. Um, we're just not going to make it overly complex. Okay. Likewise, obviously, you guys can think of 1,000 other things that you might do as far as a behavior that you as a student are going to perform, or is going to be performed on your behalf. Some of them are behind the scenes. Some of them are going to be things that you initiate. Um, and those are a good process. A lot of times when we think about object-oriented programming, we think of things that have a physical representation. Okay. Obviously, yourself as a student is a perfect example. But we can think of things like a car or a house or things like that. Um, the old idiom is, objects are like nouns. They're, person, place, or thing. Um, the thing is what makes it a little bit interesting, though, because things can be abstract. Um, and this can be abstract from a computer perspective, and it's a data connector that we have to use to communicate with a web service or with a database that's over here, or some other type of aspect. Um, it can be abstract and just a process of thinking of how do I go through something step by step by step. Those are all just kind of different things that you can kind of work with. It's up to you when you're designing a complex system where you're using object-oriented programming to define, okay, is this an object or is this something that we just need to follow through a process? Okay. What I want to do is I want to step through the process of creating a class and kind of showing what it looks like to create the class. We'll be using an example that's basically in the book that you can kind of follow along with if you'd like. Um, and that is just creating like a circle class. And we're just going to show you some real simple behaviors. I am going to warn you that some of the stuff that we're going to do is actually not what we call good programming. Um, but we're doing it for a very specific purpose. And that is we want to make sure that this is really simple, really easy to understand. So we're not going to worry about things like security and encapsulation and some other kind of high level stuff right now. We will add those concepts in later as we get closer to a more completed, essentially, project. At this point, we want to keep things nice and simple, so it's easy to learn, easy to understand. So if you're looking at those and you've done a little bit of this before, you go, oh, wait a second, that's not the right way to do it. You're going to be correct, but we're just looking at something simple to make it easy to understand, and then we will build upon it to get a little bit more and more complex. Okay, so that's what we're going to do. So the first thing we're going to look at doing is we're going to look at building a circle. And to define a circle, let me bring up Visual Studio here. Oops. I have a whole bunch of stuff from our previous example. Let me clean that out real quick. Okay. So I've got um, a blank empty file here, and I need to define a class. So defining a class is very simple in C++. We use a class keyword, and we give it a identifier, okay, our class name. So we'll call it circle. We have an open and close brace. And if you notice, Visual Studio did this for me automatically. Now, if you're not able to use Visual Studio, this is a key thing that you do need to remember, and it's very easy to forget. Um, and that is this semicolon is right here at the end of my class. Okay. Your class definition needs to end with a semicolon. That's just one of the rules. Okay. Normally, we don't have to do this at the end of a closing brace. And that's why it's easy to forget. I do not know why it's different. The creators of C++, said, let's just do it different this time just because. I don't know why they did it. But that is one of the rules. So we specify class. We use that as a keyword. We specify the class name. And we have braces with the semicolon. Now, one thing you do notice, if you notice a lot of stuff that I've done, I've tried to mimic good programming practices and things that are pretty standard in C++. You notice all the method name or function names I've created, all the variable names I've created. they all start with a lowercase. That's a pretty standard instance. The exception being if I have like a global constant, my constants tend to be all uppercase. Now, if I have more than one word in it, so if I have like today's temperature, the first T for today is lowercase. The second word, temperature, um, a lot of times I'll make that a capital T, just to make it easier to read. But if you notice my class name, you'll notice that the C in circle, or the first C in circle, I should say, is capitalized. And that is not a mistake. It is standard practice to capitalize all class names. If you have more than one word, so if you had, uh, something else that had multiple words, the first letter of every word, including the first word, would be capitalized. So that's a pretty standard um, implementation for your class object names. The second thing that I do want to point out is that we are going to give what we call the access level. We're going to find that real quick and just going to say public with a colon. And then we're going to specify any class level variables. So we're going to create one. This is going to be a type double. And this is going to be radius. As we're dealing with a circle, radius is a real important value, obviously. Okay, so I've got my public, I've got my double radius. We're good there. We're going to go a little bit more into that a little bit. We're just kind of taking a real high level overview at this time. All right, so the next thing that I'm going to do is I need to create what's called a constructor. A constructor is a special method which is called when you go and create an object. Okay, so your class definition that we have here, okay, is think of it like a blueprint. Okay, blueprints are nice; they're very helpful. If I have a house set of house plans that they call them blueprints, and it tells me how this house is going to be built. It gives all my dimensions, and it's going to show where the plumbing goes, where the electrical goes, and all that type of stuff. Um, Depending upon how complex of a system you have, whether you're dealing with like a house or an office building or a high-rise office building, you might have anywhere from 8 or a dozen pages up to dozens upon dozens upon dozens of pages of blueprint plans and schematics for security wiring and HVAC and plumbing and electrical wiring and all these different things that wind up being put into place. Okay. However, no matter how good or how detailed those blueprints are, you can't go live inside them, right? There's no house. It just tells you how to build the house. And that's kind of like what your class is. Your class is that blueprint, but you can't do anything with it. Not until you build what they call an object. To build the object, you have to have the constructor. The constructor is literally what constructs that object from your class. And the object is just a special name for the variable of that type class. Okay, so there's a few things in object-oriented programming where names get changed, just so you know that you're dealing with object-oriented programming. Classes are our data type, if you would. Object is the variable. So we've worked with like doubles before. Our class is a double. Uh, it's a variable with a data type. A class can kind of be thought of as a complex data type, and then the object is that name. Okay, so let's talk about how we're going to build a constructor. Well, my constructor is going to be based upon the same name as my class. So I'm going to say circle. So I double new radius. And then I'm going to say radius equals new radius. Okay. I want you to notice a couple of things about the constructor, just real quick. Um, and we're going to go, like I said, into more detail about constructors in just a few minutes. But I've got radius here, and this radius is the same as this radius. So in a class definition, I can define a class level or an object level variable. This is not a global variable. It is only accessible inside my class. But what's really helpful is I can access this variable in other functions of my method, or excuse me, other methods of my object. So I can use this over and over and over again in different places. And that makes it very helpful. I can set it one place and then I don't have to worry about where else it is. And if you remember to give me a value or anything, I can just go in and call and use it. Let's take a look at an example of that. I'm going to create a method called getArea. Now, getArea is going to return a double. I have my function name. And we've done this before with finding out the area of a circle, but we've always had to pass in a radius. Well, now we don't need to. And the reason why is very simple, because I have a class level radius. And I can simply come here and say, return radius times 3.141592. Okay. Because I have the radius as a class level variable, it gets set. I know what it is. I can pull and use it in this method. I can do it in other methods. I can have a dozen methods. So if I added another method, double get diameter, return radius times 2. Okay. It's very simple. And this means that I don't have to keep on passing in values all the time. I know what my value is. I can just go in and test it and make it work. And that's what I really want to do, is to just do something very simple like this. Um, Makes it very, very easy to use. Makes it easier to use because I'm remembering my values for my object, so I don't have to keep on passing them in. So a lot of good things come from this.
Just a quick question about the variable thing.
Yes. Let me come back here. Okay, yes.
When you did the double new radius thing, would you have to do that for each kind of the thing you did there? So like you know you have double radius and then you had circle double new radius to define it. Would you have to define each one of those things you'd put in the class?
So yes. So if I had, let's say that complex, let's talk about the student again, and I had first name, middle name, last name, etc. I would need to define every property that I want to know about and use throughout my class. So I have to, just like I did up here, double radius, I would have to have string first name, string middle name, string last name, string major. I would use a date object for an expected graduation date. I might have an int object for number of credits taken, um, all those different types of things. But you are correct. I would have to define every parameter or every object level variable that I want to use. Um, this is a little bit different than if you remember in Python, where you didn't have to. You could just use it, and once you used it, it was defined. And this requires a little bit more of a definition. Python is, it seems easier, but I really don't like the way they do that. And the simple reason why is because I'm always concerned that it's going to, um, if you have a function that needs of object level variable, it may not be there ready for you if you don't call that right preceding function or something like that. So this, I think, in my opinion, just based upon my experience and stuff like that, um, while it takes a little bit more setup time, it's really not that much longer, and I think it really reduces the number of potential errors you could run into, especially as your applications get more and more complex. So that's my opinion, and you can take it for what it's worth, but that's my opinion on it. And so, but yes, you are correct. You have to define all of your properties before um, you can use them. Okay. We talked about constructors. Um, we're going to go back and talk about constructors a little bit more detail in a few minutes. We talked about our methods, okay? And so we can kind of look at all these examples and we see how they're working. Very simple, very easy to use as far as that goes. Now, one of the other things that we can wind up doing is we can go through the process of we've got our class, but now we need to create that object, okay? So I'm going to come back in here into my main function. Need to return 0, it's not doing that. And I want to create an object based upon this class. So remember we said the class we can think of as like our data type. So I'm going to specify circle, and then I'm going to say circle 1, and I'm going to specify a value of 10. I'm going to give it a default radius. Then I can do something like, say, cout when a circle's radius is, and then I want to access the radius. Well, like I said, we've done this in a way that's not really safe, but I'm going to show you how to do this because we can access that radius property directly. I'm just going to say circle 1 dot radius. And so I specify my object name, a dot, and then the property of that object. Very, very simple, right? And that's the way it's designed. Notice that radius doesn't have to have parentheses or anything of it. It is a straight data type. Come over here and say, then the area is, I'm just going to drop down to a new line and make it a little bit easier to read. Once again, we have our object name, circle1 dot get area. And because this is a method is a function that's inside of a class. That's all it is. So methods and functions, you can think of them interchangeably. Technically, they are methods, not functions. This is kind of like the difference between a meteor versus a meteorite. A meteor is a chunk of rock out in space. A meteorite is that very same chunk of rock that's now entered our atmosphere. It's the same rock. Okay, it's just a different way of naming it based upon some status. A function, a method is a function. It's just that it belongs to an object. Okay, because of it, we need to use the open and close parentheses. And like that. Now, if we go to run this, when a circle's radius is 10, then the area is 314.159, which is exactly what we expect. Okay, 10's a real easy one. I could come in here and change that 10 to be 7.2. If I go and run this again, it's going to come back with a completely different number based upon what that radius is. So very simple as far as that goes. You don't have to update where my radius is in 2 or 3 or 4 places like I might have had to before. Because it's a class, all I have to do is define it one place, and then I'm just referencing and making those calls and those method calls. It makes it very, very simple as far as that goes. Okay, and I can have another circle and do the same type thing. So I'm going to say circle, and I'll just call this one circle 2. Oops, that's not what I wanted. If I come in here and change the object that I referenced from circle 1 to circle 2, I'll get 2 lines, one for my first circle, circle 1, and one for circle 2. Okay, so, and the really nice thing, and the thing I really want to point out with this is notice that I'm using the exact same call. So it's circle1.radius and this is circle2.radius. Both are the same property name, but because they belong to a different object, okay, one object is circle1, one object is circle2. These two values are completely different and all their properties are completely different. Okay, think once again about the idea, if you would, of your students, and you think about the person who sat next to you in class, or 3 rows down from you, or anything like that. Of course, our classroom didn't have rows, so that's a different story. Um, but if you think about other students in the class that are with you, your properties are not their properties. You all have your own separate information, and that information is designed to be kept separate. So even though we reference the same property or the same method, the object names are different, and therefore we know the compiler, the program, knows which property to go reference. It has no confusion to it at all, because it knows, oh, this property belongs to this guy over here and this property is that guy's. um, Even though they have the same name, you can keep this all very straightforward. And that's a very important thing, kind of get your head wrapped around. um, when I was first learning object-oriented programming, this was one of the things that I kept on going, well, wait a second, how does it not know that this radius is not that radius? How does it not get confused? I mean, I'm confused looking at this. And the idea, and I wish that someone had told me this, was, think about yourself and think about the person sitting next to you. You have a lot of the same properties. Um, and depending upon the relevance is going to, to the application, is going to depend upon what's there. Um, as a student, I don't care what color hair you are. But on the other hand, every driver's license has your hair color, your eye color, all that type of stuff as part of it. Um, so, you know, I have an eye color. My eye color is brown. Other people have brown eyes. That doesn't mean it's the same thing, same value. Um, because the person right next to them, they might have hazel, or the person 2 rows over, they've got blue eyes or green eyes, or anything else like that. So it lets us keep it separate. It lets us know, be, because of the object, its properties about that object are unique to it. Even though they share the same name, it's unique to that object. And that's a real important thing. And once I got that kind of an understanding through my own head, I was able to remember that. It made object-oriented programming and the logic and understanding of what I was doing just kind of really fell in place. It was a lot easier for me. So I was very thankful once I got to that point. Took me a while, but once I got there, man, it made understanding object-oriented programming so much easier. So I just want to kind of, that's why I've emphasized it so much, is because I know it will really, really help. Okay. Um, so we talked about that. We talked about that. Okay. Let's go into some additional things about the constructor, because constructors are an important thing. And a lot of people will try to either do too much or too little with constructors. So let's talk about a couple of things. All right. So let me come back up here into my constructor, and let me specify this. If I come in here and do something like radius equals 5, this is not good object-oriented programming. If I run this, notice that Visual Studio lets me do it. Okay. Not all compilers are going to let you do this. So keep in mind if you just because one compiler lets you do it doesn't mean that all compilers are going to let you do it. But this is also considered to be bad form. Your radius should all or any property should never be set where you define it. Okay, you always want to set its value inside of a constructor. Now we have a constructor here that takes the radius, but what happens if I didn't want to give it a radius? So if I came down here and said circle and gave it the object name was circle3, notice that it does not show an error. Okay, kind of a weird thing, right? If I go to run this, notice that it even lets it run, even though we've not defined a constructor that doesn't take a parameter. Okay, that is a little weird. So let's talk about what's happening. So notice, if you would, that circle does, it's a slightly different color. So instead of being blue, it's beige, brown, and it's hard to tell what color that is. But it's a different color. And the idea is that we don't have a constructor that doesn't take a value. Now, when we could call it like we did, what happens is that there is a default constructor that gets called. It gets created. Problem is, who knows what that radius is going to be? Okay, I don't have any control over that. If I come over here and just duplicate this value, I'm just going to say circle 3 radius and circle 3 get area. Notice now it's starting to give me errors. Why? Because I didn't give it that information. So it starts to get really confused. Okay. So let's fix that real quick. And the real simple fix of this is going to be, I'm going to create a constructor, circle, that's not going to take any parameters at all. And I'm going to specify my radius. Radius equals 5. Ah, hold on. Why is it not liking this? Let me make sure it's not. Okay, I got everything spelled right, right? Does anyone see misspellings? Okay. Ah, circle 3. There's my misspelling. What? You ever have something you're like, I swear this worked yesterday? Because I swear this worked yesterday. sure I didn't misspell something in here. That's right. That's right. That's right. Just one more time. Why isn't it liking? Great. Okay, I gotta double check this and why it's not working. Anyway, you can let's talk about this real quick and then I'll try to see if I can figure it. It's probably staring me right in the eyes. I just don't see it because I'm being stared right at it in the eyes. So you can overload a class definition. Excuse me, not a class definition. You can overload, let me back up. You can overload a class constructor. Okay. So if I have a class constructor like this that takes no arguments, then I wind up having a method that I am using, okay, so where I need to define all of my values. So I can go and define all my default values. In fact, a lot of people consider this to be kind of a good methodology of saying, I want to call this method, define all my preset ones, and then only change the values I need to. So that's a pretty common thing. I'm just gonna, just for giggles. Nope, that wasn't it. Um, okay. Notice that your constructor does not return a data type. And that's another key important thing to notice. Your constructor does not return a data type. That's because what it's not even returning void. Depending upon your compiler, if I put void in here, notice that Visual Studio gives me an error because this is the error down here. Member function with the same name as its class must be a constructor, and a constructor does not have a return data type. That's because it's essentially returning the class name. Okay, uh, that's essentially what it's doing. Therefore, you cannot have a return data type. You can't put circle as a return data type because it hasn't been defined yet, because you've got to build that constructor first. So you don't ever give it a return data type. Some programming language or programming compilers, so some C++ compilers, will let you have a return type in the name of a constructor. However, a lot of times they do not treat it as a constructor. It's treated as just another method. So that becomes a real problem. Let's get rid of that. It was driving me nuts. Okay. So make sure that you do not have a return type. Typically, you will have a constructor that doesn't take any parameters. This is sometimes called a no arg or no argument constructor. If you do not define one, you get the default constructor. And we'll talk about why you have a default constructor when we get deeper into object-oriented programming and understanding about classes and stuff like that, even more with your classes. So do keep that in mind as well. Other things that you want to know about. Let me just because we're getting this as an error. Let me just comment this out real quick. Okay. I can come in here and specify circle 1 equals circle 2. Okay. This is going to make a shallow copy of all of my data inside of circle 2 and copy it over to circle 1. So if I go and run this, you're going to find that the um, radius was copied over. And because the radius was copied over and any other properties I might have had, then you can see that my area and my radius is the same when I print out that information. So I can do a copy. Now, technically, this is what we call a shallow copy. And we'll talk about more about that as well as we go through this process. Oops, there we go. But as a shallow copy, we're just copying over all those, what we sometimes refer to as primitive data. Now, another thing that we can do is, let's say I wanted to figure out what the radius, what the area was, but I didn't need to create an object because all I was doing was just calculating what the information was. So let me come down here. Let's show you an example of that. When the radius is 5, the area of a circle is, and what I'm going to do is I'm going to create what we call an anonymous object. An anonymous object is one where we string an extra method after we create the class. When we create the object from the class, though, we're not going to store that information. So as soon as the line gets run, it's also forgotten. So we literally create the object, get the information we need, and then dispose of that object. The way I would do it would be circle, let's say 5, because that's the radius I specified before. Then we're going to specify get area and down. Now when I run this, I get my first 2 just as I expect. But here is that anonymous function called. We hard coded in the 5, and then we get this value out. And this value is, it goes in, it creates an object, it allows us to run that get area, but because it's not stored inside of a variable, that information is completely lost. I have no way of accessing that information again because that information is lost to time as soon as that line of code runs. Okay, that's sometimes called an anonymous object. Makes it really easy if I just got to do something really quick, but I don't care about keeping it. Makes it a little bit more efficient memory-wise as well. However, 9 times out of 10, you're going to need to have that object. You're going to need to keep that reference information. So do keep that in mind as well. Okay. Any questions on that? No? Awesome. Okay. So we've got we're done just a few minutes early today. Notice, if you would, that we didn't get kicked off at 40 minutes. They expanded, they gave me one of the higher paid licenses because of all the work that we've been doing the last couple of weeks in class. So I wasn't sure if it was going to be ready or not. They told me that we were going to get that on Friday. They went through and they were looking at all the people who were using Zoom and how much. So it's cool. Now we get to have one big thing. We don't get interrupted and cut off in the middle. We are done a few minutes early, so um, I'm going to let you go. I'm going to stay on the line though. If you guys have questions or comments, feel free to stay on the line and ask them. If you're good to go, then you're good to go. And I will see you on Thursday, and we'll talk more about this. I'll try to figure out what's going on with that one thing, and I probably just got a misspelling or something somewhere in there. It drives me nuts, but hey, it is what it is. Um, and we'll keep going on learning more about that. If you want to read up a little bit in advance, um, this is all chapter 9 from the textbook. I've also got the notes online that has some additional information, has the information that's inside the book, has some additional information. I hope that it would make it just a little bit more clear and whatnot. So, but if you have any questions, you guys are more than welcome to stick around. Otherwise, have a good rest of your day.